in 1998, another organization, the Third Generation Partnership Project, continued the technical specification work for standard. Basically, they keep adding and improving the IMT 2000. Okay. Just for the historical context, in Europe, the European Telecom Standards Institute, ETSI, were responsible for the definition of the UMTS standard. And the result of that is the 3G evolution. And the principle of UMTS is to reuse the network architecture of GSM so that they can reuse the equipment as much as possible from the second generation networks. They don't have to buy new equipment, but instead only upgrading the equipment. So that's the network architecture. So, and then using that network architecture, they can improve the throughput, improve the data rate, enhance the data rate using new air interface technology, which is in this case wideband CDMA. So last time we'll talk about CDMA. So we have an idea of what CDMA means: code division multiplexing. How we can allow multiple users to share the same frequency at the same time, right? Using different codes so that they do not interfere with each other. They can share the medium simultaneously without interfering with each other. And because of this air interface, the data rates of 3G networks are much higher than the data rates in 2G networks. Okay. All right. So, and these are the data rates for different type of 3G services. Okay. So before we go into the data rates, we need to define different type of cells. All right. We have macro cell, micro cells, picocells, and then another type of cell, which is a femtocell. Okay. So just go very quickly about over different types of cells. So macro cells is the largest type of cell base station. So if you drive on the highway and you see those cell towers, they are macro cells. Okay, they are deployed on a tower, on a water tank, on a rooftop. So basically, they are the largest type of cell base stations. And then a microcell is smaller than a macrocell. When we say smaller, the size is smaller, of course, but because of that, they cover a shorter range. So it's low power, and it's designed to serve a relatively small area, such as a residential neighborhood, an office complex, a campus, an airport. So the maximum range is about 1.2 miles or less. So basically, it should be less than 1 kilometer, around that, approximately 1 kilometer at most. So because of this, it's easy to and quick to deploy microcell base stations. It is cost effective and it minimizes the impact on the surrounding areas because it's small and it serves only a small area. So, and then the next type of cells is picocell. So a picocell is also a small mobile base station. And we use picocell to improve the in-building cellular coverage. So remember, in a previous lecture, we talked about some building having a kind of metallic cover outside the building for environmental purposes to reduce heat or to reduce the cold. Those metallic cover would reflect the signal, and the signal cannot penetrate the walls of the building. So in that case, we can deploy a picocell inside the building, and then we connect the picocell with a macrocell or a microcell outside using wires. So picocells they are deployed inside the building in that case in order to help with the coverage. And they have a range of about 200 meters or less. and they cover a small area such as inside a building or recently in aircraft as well. So local area networks access point is basically a picocell by itself, right? Because an access point can support the range of about 100 to 200 meters. Okay. Right. So now the difference between macrocell, microcell, and picocell, the main difference is the area of coverage. So macrocell base station can cover areas larger than 1 kilometer. And then microcell base stations can cover areas between 100 meter to 1 kilometer approximately. So, and it takes about 3 to 5 microcells in order to provide the coverage similar to that of one macrocell. And picocell can cover areas of around less than 200 meters inside a building. And then there's another type of cell which is even smaller, which is femtocell. So a femtocell is even smaller, the smallest kind of base station. So it's designed for use in a home or business. And it could support about 2 to 4 mobile phones in a home, or about 8 to 16 mobile phones in a small business. So again, we use this in case the signal penetration in the building is not good. So we can use a femtocell in this case to increase the coverage inside the building. All right, so those are different type of cells. Now, and because of different type of cells, we can have different data rates for 3G services. All right, so remember, the shorter the distance, the higher data rate that we can use, right? The shorter distance, the higher the data rate that we can use. So that's why for picocell, we can support up to 2 megabits per second data, all right? And then if we increase the range of a base station for macrocell or microcells, then the rate is reduced to about 384 kilobits per second, all right? If we increase the range even further for large macrocells, then we reduce the rate to about 144 or 64 kilobits per second, right? And in very large cells, again, about 14 kilobits per second for low speed data application, and about 12 kilobits per second for speech. Now, if we use satellite, remember satellite is very, very far away. So again, very low rate, about 10 kilobits per second, right? So one thing about 3G networks is that they coexist with 2G technologies. So basically the new technology in 3G networks will coexist with the previous technologies and equipment in the base station shelters. So that means 2G and 3G will coexist so that we have a continuation of services for subscribers who had 2G devices, who had 2G services before, all right? All right, so now we'll go into UMTS. All right, so UMTS is a standard, all right? So again, it's a standard for 3G networks. It's a broadband and packet-based 3G standards. It allows transmission of text, voice, video, multimedia at data rates of up to 2 megabits per second, right? So we've seen this here, right? The data rate up to 2 megabits per second for picocell application. Sorry. So it is based on GSM standard, right? So we learned GSM last time. GSM is the second generation networks. So 3G or UMTS reuses the network architecture of GSM. And it's similar to GSM, it uses packet switch connections based on the IP protocol. And it was developed mainly for countries with operational GSM networks because we need GSM and we reuse the equipment of GSM for UMTS. Okay. All right. right? And yeah, the idea we emphasized before, the 3G project kept the core network of 3G networks as close as the GSM core network specification as close as possible in order to reuse the equipment in GSM networks. And in UMTS, there are two types of operation for uplink and downlink. Remember, we said before, the uplink is from mobile phones to the base station. Downlink is from base station to mobile phones. We need both uplink and downlink so that we can have duplex communications. So in UMTS, they use both frequency division duplex and time division duplex. So with FDD, we have two different frequencies for the uplink and downlink. Each has its own frequency. For TDD, we use one frequency for both the uplink and downlink, right? And then that frequency is divided into time slots, and each user will be given a time slot on that frequency. And we said before that TDD is better than FDD when there's asymmetry of the uplink and downlink data rates. So because we use time slots, so if it doesn't matter uplink or downlink, the user is given a time slot. So in that case, we can maximize the usage of the frequency, right? So TDD has an advantage over FDD in that case when the uplink and downlink data rates are not symmetric. Okay. All right. So UMTS is better than 2G technologies for sure, right? Because of the following characteristics. First, the voice quality is much higher. It can support up to 2 megabits per second data rate. And it provides a virtual home environment in the sense that users are given the same personalized features everywhere when he or she moves from one base station to another, from one area carrier to another carrier. They are given a consistent personalized features in that sense. And it has much improved network security and location-based services. All right, so and then this is how service providers migrated from 2G to 3G. So for 2G, at the beginning, we have GSM. And then they build GPRS for data services on top of GSM. So GSM has only a circuit switch domain, as we said before, only circuit switching to handle voice. GPRS now has packet switching services to handle data services. So in this case, from GSM, and then we overlay GPRS on top of this, we need to add hardware, right? Because the hardware is the packets switching components. And then, of course, we need software as well, changes as well. And then Edge, we said before, is an improvement over GPRS. So in this case, we change only the software to support Edge over GPRS, right? And this is 2.G and 2.75G. So when we move from 2G or 2.5 to 2.25G to 3G, of course, we need to upgrade some hardware and software changes, right? And then the missing text here is plug-in assisting frame. Okay, sorry, this one was drawn by one of my TAs in the past, and I think he couldn't read the text in the diagram, so he put it here. What I mean is plug-in assisting frame. Okay, and I could not find the original file that he gave to me to change this to this, so I only got a screenshot of this in the slide. But the question mark here is the existing frame. Okay. All right. So yeah. So to go from 2G to 3G, we need both hardware and software changes. okay? All right, so now we'll talk about the UMTS network architecture. So it's contained of three interacting domains. One is the core network, okay? And the second part is the UMTS, terrestrial radio access network, or they call it UTRAN. And it provides access to the network using wideband CDMA. Okay, so we'll see the diagram later. And then we have the user equipment, which is mobile phones. Okay. All right. So this is the UMTS, sorry, it should be UMTS network architecture. Okay. Let me check this here. All right. So this, you can see here, this is a hybrid of 2G and 3G. Okay, so let's consider each component. So this is the core network. Okay, so this is the core network. So in the core network, we have two components, two domains, just like in 3G. In 2G. One is the circuit switch domain, and the other is the packet switch domain. So the circuit switch domain is for voice, and the packet switch domain is for data. All right. So this is the mobile switching center, mobile switching center to handle voice connection. And then it is connected to a gateway mobile switching center. And from this gateway, it is connected to the public telephone service. All right, so this is for voice. And then, of course, the switch has access to a database, which is the home location register that contains information of the subscribers in the network. Of course, we have another database, which is VLR, which is visitor location register, but they don't show it here, right? But we have VLR as well. So this is the voice component, all right, the circuit domain, the voice component. Now this is the data component, okay? So this is the serving GPRS support node, right? The serving support node. This is the gateway support node. And this is the gateway is connected to the internet, right? To the internet, so this is the internet here for data. So this part uses packet switching, and this part uses circuit switching, all right? And then both components is connected to something called GRAN or UTRAN. So this belongs to the GSM network, the 2G, right? So 2G and 3G now coexist in order to provide continuation for 2G subscribers. And we've seen this before in a 2G network here. We have the base station, base transceiver station, and base station controller. Okay. Now in 3G network, we have the same configuration, but now we don't say we don't call it base station controller anymore. We call it radio radio network controller. Okay, it's called RNC, radio network controller. We don't call base station controller anymore. We use a different name. And then instead of calling base transceiver station, now they call it node B. All right, so but basically they are the same thing, just different technology, 2G or 3G, different air interface. Okay, so when you see node B, what it means is it's a base station, and that's it. Node B means a base station. BTS, a base station. Okay, and they operate in parallel. They coexist in the same network, okay? And they share different elements. So both the mobile switching center and the serving support node, they are connected to the RNC, or they're connected to the BSC, right, as before. Okay, all right. So and so as we see in here in the diagram, the UMTS network operates as an overlay over GSM and Edge networks, right? So it's overlay because this is the architecture of GSM and Edge. So it works on top of this. And then UMTS radio equipment is installed side by side with GSM-based equipment. Okay, so this is the equipment for the air interface, right? So they are installed side by side. That means in the same base station, you would have an interface for 2G air interface, and you have another equipment for 3G air interface. The core network is based on the GSM architecture, right? And we use the GPRS and the Edge data protocols as the foundation for the data transmission in the network. Okay, and then the base station now is called a Node B, right? We don't call it BTS anymore. And the radio network controller obviously control the equipment for the base station for the Node B. So it's equivalent to a base station controller in GSM networks. Okay, so this is the high level architecture of UMTS networks. All right, so one point about UMTS that's different from GSM is that the network is divided into geographic boundaries, or we call it system areas, in order to determine the user's approximate location in order to terminate a call. All right, so when the user moves from one area to another, we need to determine their approximate locations for the handoff, for example. In order to do this in UMTS, they divide the geographic boundaries into system areas from largest to smallest. So if we go from the top here to the bottom of the list, it goes from largest to smallest. So basically it's the UMTS systems, everything in the UMTS system. And then the public LAN and mobile network. And then it's go down to the mobile switching center and the VLR or the serving GPRS support node. And it go down to location area and then routing areas and then UTRAN registration area and then to the cell and then subcell. All right. So these are the system areas defined in UMTS. We're not concerned with how big they are, right? And what the boundaries. We just know that these are the different type of system areas defined in UMTS in order to determine users' approximate locations. Okay? And then UMTS defines different quality of service classes. There are 4 types. The first one is voice, all right, or they call it conversational class. It's for voice, video, phone, and gaming. The second class is streaming class, such as multimedia video on-demand webcast. Third class is interactive class, just like web browsing, network gaming, database access. And then the last one is background class, which is email, SNF, and downloading. This part doesn't require real-time interactions or high data rate. Okay. And depending on the quality of service classes, the network will provide the appropriate data rates to each type of class. Okay. All right, so now we go through the 3 elements of the UMTS network architecture, right? Remember, we said we have the core network, we have the UTRAN, and then we have user equipment. Okay, so now we'll talk about the core network. All right. So the core network, again, is based on GSM technology. And they use Edge, GPRS and Edge as the data network foundation. The core network provides both circuit switching and packet switching. Circuit switching is for voice, packet switching is for data. Okay. And it contains the databases, the network management function as before, the home location register, the visitor location register, and the EMS, which is element management systems. So EMS manages elements, network elements and equipment such as base station equipment, network radio controller, switches, peripherals, input-output devices, for example. Okay. All right, so, and the voice transmission are routed to the circuit switch domain. The packet-based transmission or data are routed to the packet switch domain. That's obvious, right? And some of the circuit switch elements are the mobile switching center, the BLR, and the gateway mobile switching center, as we've seen before. Okay. All right. So, so here, so basically this one here, right? So this is the mobile switch center, HLR, and the gateway MSC. Okay, and then we have elements that support the GPRS and Edge technology, right? So which is this part here, all right? And then we have, sorry, let me see now, okay. And there's something called number portability database. So this database allows users to change network providers while keeping the same phone numbers. All right. So in the past, in 2G networks and 1G network, that was not possible. But in 3G, user can change service providers and keep their previous phone numbers. Okay, so this is a convenience only in 3G networks. Right. So that's the core networks. Now we talk about the UTRAN, terrestrial radio access network. So basically this component here. Okay, so this component here. So in this component, we have the RNC, right? So, and the function of the RNC is to connect voice call to the mobile switching center and connect data services to the serving support node, or we call it packet data service node, right? In 3G network, it's also called packet data service nodes. Okay, and and of course the UTRAN network here is divided into two domain, circuit switch and packet switch, just like with the core network, because we need to handle voice using circuit switching, and we handle data using packet switching. Okay. So in the voice domain, the RNC is connected to the mobile switching center. And then the gateway mobile switching center connects this part to the public telephone network. In the data domain, the RNC connects is connected to the serving support node, or the packet data service node, right? And then we have a gateway here, right? The gateway support node is connected to the internet. Okay, so that is the description of the UTRAN component of UMTS networks. All right, so now for the node B, or base station, all right, so of course the function is for transmission and reception of signals. It's modulate and demodulate signals for transmission, and they use CDMA, wideband CDMA, as we learned CDMA last week, and it's also for error management, for power control as well, as we said before. In terms of power control, if a station moves closer to, sorry, if a mobile phone moves closer to a base station, then the base station will tell the mobile phone to reduce the power. If it moves farther, so the base station will tell the mobile phone to increase the power, okay, based on the distance. Right. So so the RNC here, all right. So the RNC. So the RNC has many functions. Radio resource control, admission control, channel allocation, allocate channel to mobile to different base station, power control setting, again, to make sure that there's no interference and to minimize power consumption, handover or handoff control, encryption of data, segmentation and reassembly of packet-based transmissions, right? So if you learn about the IP protocol before, you know that data have to be segmented and then transmit. And when it arrives before the destination, it will be reassembled into the original packet. And broadcast signaling as well. All right, so those are the main function of the RNC. Okay. So the user equipment, mobile phones. So mobile phones, now again in 3G networks, both GSM and UMTS can coexist. So that's why mobile phones will automatically search for a UMTS frequency or channel first, right? If it cannot find a UMTS frequency or channel, then it will step down to GSM if UMTS capacity is not available, okay? Because both 2G and 3G networks are existed in the same domain, in the same space. All right, and then inside a mobile phone, there's something called UMTS IC card. So an IC stands for integrated circuit. Basically, this is a SIM card, right? This is a SIM card. So in GSM we call it SIM card. In UMTS we call it USIM card. It stands for UMTS Subscriber Identity Module. It's called USIM card. It can support one or more user profiles on the same card, and it can update USIM user specific information over the air. It provides security functions. It provides authentication, right? And it also includes payment methods as an option, and also allows for secure download of new application as well, right? Okay, so those are the main functions of UMTS SIM card. Okay. All right, so we've gone through the network architecture of UMTS. Sorry. Okay, network architecture. Now we'll talk about a little bit about wideband CDMA technology, right? So again, in 3G networks, we use wideband CDMA. And at the same time, we have two basic modes of operation to implement duplex communication. And 3G uses both FDD and TDD, right? And FDD, we use two different frequencies for the uplink and downlink. And we use for both voice and data. With TDD, only one frequency is used, and then the frequency is divided into time slots given to users in the uplink and downlink, right? And wideband CDMA is the air interface technology of UMTS. It's first launched in 2001, and what we learned last time, CDMA is narrowband CDMA, which uses 1.25 megahertz carrier. And then the wideband CDMA in 3G is 5 megahertz wide carrier, all right? And again, like CDMA, WCDMA is a breadth spectrum modulation technique. Okay? We did not cover spread spectrum in this course, but we know how TDMA works. Wideband CDMA works on a similar concept. They're not exactly the same, but a similar concept. Okay. So CDMA 2000 is the North American version of wideband CDMA. Okay. It falls under a specification known as IS 2000. And again, IS stands for interim standard. And 3G CDMA system deploy more carriers in the base station than the previous 3G networks. Basically about 6 to 8 carrier more to accommodate the additional bandwidth required by 3G system. Okay. And just as a reminder, CDMA1 is the previous technology used in 2G network, and it has been sunset, that means removed by carriers in the US, right? Now, so most CDMA 2000 networks were upgrades from existing CDMA networks. So CDMA 1 is the CDMA standard for 2G networks. And then when they move to 3G, they upgrade the equipment to handle CDMA 2000 instead of CDMA 1. Okay. And then they developed CDMA1 1X EVDO. All right, so 1X means the same bandwidth as CDMA1. All right, so 1X means one times transmission technology, basically the same bandwidth as CDMA1. EV stands for enhanced voice, and DO stands for data only. All right, so they developed CDMA 2000 based on the same bandwidth as CDMA1, and the goal is to support enhanced voice or support data only. And this standard was developed to be backward compatible with CDMA1. Right? So again, the reason is when they developed and they deployed 3G, the system was still supporting 2G phones, 2G subscribers. So that's why they have to develop this standard to be backward compatible with CDMA1. Okay, and because of that, the radio channel bandwidth of CDMA 2001X is the same as the bandwidth for CDMA1, so that they can work interchangeably, work in the same base station. So that allows for a graceful upgrade. That means we don't need to change equipment. We only need to change the air interface. And then the CDMA 2000 can have three versions. The first one is for enhanced voice only, and the second one is for data only. All right, and then the third type is both data and voice. Right, D is for data and B is for voice, and they have one carrier supporting both voice and data. In this case, one carrier supports only data services, and this is one carrier supports only voice. All right, so they have another type of air interface, which is called 1X RTT, right? RTT stands for radio transmission technology. So this still 1X, which means it still use 1.25 megahertz carrier, right? Still the same as CDMA1. But it uses a different codec for voice, right? It uses a different codecs for voice. So because of this different codec, now it can use more washed codes, right? So remember last time we talked about CDMA, we said that washed codes has 64 codes. So that means you can support 64 users at the same time on the same frequencies, right? Now, with 1X RTT, they use the same bandwidth, but now they use a more advanced codec. And now they can support 128 codes. That means they can support 128 users at the same time. And because of this, the additional washed codes can support higher data rates, right? Because now instead of 64 users, we can support 128 users. And it can support more voice conversation than with the CDMA platform. Instead of 64 users, now we can support 128 users, all right? And the chain is only the using a different codec, okay? Codec means coder and decoder. the signal will be decoded and decoded, just like we talked about last time with CDMA, right? Okay, so now this is the CDMA network architecture. Okay, it's the same, very similar to what the architecture we've seen before. Okay, the only thing, and similar to the 2G network as well, right? So we go through each of these in turn. So again, this is 3G networks, all right? We have the core network, right? And this is the UTRAN, right? The UTRAN we talked about before. Now in CDMA 2000, they call it access network, right? And this is the user equipment. So in the core network, we still have the mobile switching center, okay? We still have the mobile switching center. We still have the home location register and the visitor location register. Here they call visiting location register, VLR, but still VLR. So this will be used for authentication, all right? Just like before. And then there should be a gateway here, right? And so I think they combine both into the mobile switching center here, and it is connected to the public switch telephone network as before. Okay, so this is the voice domain. This is the voice domain. Okay, and then this is the packet switching domain, the data domain, right? So we have the packet data serving node, which is equivalent to in GPRS, that is serving GPRS support node. Okay, so that's equivalent to that. And then we have something called CHOC router. So this is equivalent to the gateway support node in GSM or in UMTS. This is the gateway, right? So the gateway support node connects the packet switching domain to the internet. Okay. And then we have the AAA server. AAA stands for authentication, authorization, and accounting. All right. So basically, it's served for the purpose of authentication and accounting. So it's equivalent to the authentication center in the GSM network. Okay. And then we have something called network management system server. So this is equivalent to the operational support center that we've seen before, right? In 2G network, this is the brain of the network, and everything is connected by a router for sure, because now this is the packet switching domain, so they have to be connected using packet switching or router to talk to each other. Okay. And now we have something called the foreign agent and the home agent, all right? So what is the foreign agent and what is the home agent, okay? So now the foreign agent and the home agent support roaming. So when one mobile subscriber, one mobile user roams from one network to another, from one carrier to another, the foreign agent and the home agent work together in order to deliver data to the user, okay? So you can imagine, I'll just use an analogy to explain the purpose of the foreign agent and the home agent, all right? So assume that your home is in, let's say, Alberta, right? In Calgary, for example, you live in Calgary. Now you go to York University to study, all right? So when you arrive at York University, you stay in the residence, right? You stay in the residence at York. So you stay in a residence at York. So if someone sends you a letter or a package, then the residence manager would receive the packet and then deliver to you, right? So the address of the residence is called a care of address, care of address, all right? And the residence manager serves as the foreign agent. So the resident manager acts as a relay between the post office at your home and the resident and the residents here. So basically, when the post office at your home in Calgary send you a packet, the resident manager receive the packet and then give it to you. All right. So the resident receive all the packages, all the letters, and then give to you. All right. So you can imagine the residence manager as the foreign agent. All right. Okay. And then you have something called home agent. So the home agent can serve as the post office in Calgary. So the post office in Calgary maintain an association between your address and the resident address, right? So when a package arrives for you at the post office, they will forward that packet to your residence at York, okay? So they basically, the post office in Calgary redirects and internal packages to the residents for you, okay, to the resident for you, to the foreign network. So to you, the resident at York is a foreign network, and your home in Calgary is the home network, okay? So you can imagine, in that sense, the home agent is the post office in Calgary, your home, and the foreign agent, sorry, the home agent, foreign agent is the residence manager at York University. All right, so that's the purpose of the foreign agent and the home agent. Okay. All right, so that's the core network for the UTRAN or the access network. Okay. So basically, these are the radio network controller we've seen before. Okay, so these are basically this one here. Let me show. Basically, this one here, right? The RNC. All right. But now the RNC are more specific. They can be the a radio network controller that uses the 1xEV or DO service, or it can be 1xRTT service, right? So RTT would have higher data rates here. So this is the same data rates as CDMA1, okay? So they have different type of services here, okay? And they also have a authentication, authorization, and accounting server as well in the access network, right, in the UTRAN. And these are the base transceiver station as before, the base station to transmit and receive signals from mobile users. All right. Okay, so that's it. Any other components here in the architecture you have question? All right, so basically this is the network architecture of CDMA 2000. You can see that this is based on this architecture, right? Exactly the same as this, but they just change the name, the terminology. Basically, this is also a radio network controller. They just the same thing, but they use different services here. And the same, basically the same architecture, except that they have the foreign agent, home agent, and they have a specific authentication center called AAA center, all right? Other than that, it's the same architecture as the UMTS architecture. And again, UMTS is based on GSM architecture, okay? And this lecture is from chapter 8 in the textbook Cellular Networks by Paul Badel, okay? So if you have any question about the lecture, feel free to ask. Otherwise, we'll take a 5 minutes break and then we'll be back at 3:30. Okay, and we'll talk about the final exam. Sorry, we'll take about 10 minutes break. We'll be back at 3:35. Okay. Any question about this? All right. So yeah, so we'll be back at 3:35 p.m. Okay. Okay, we'll take a 10-minute break.